In this video, we'll be going over how to configure your SCADA Data Gateway. We will be including devices from IEC 6870-5-101 and 104, Modbus, and DNP3. Now, in order to get a gateway to work properly, you need to be in a network of devices. In this example, we're going to be taking data from our RTUs and mapping them over to a DNP3 master SCADA or a 104 master SCADA. So in order to set up that environment, instead of having the physical devices on my desk, I have created a simulation in DTM that is shown here. So we have all of our RTUs, or our downstream devices, and I have 3 of them set up. I have a Modbus slave, a 104 control station, and a 101 control station, each with various data points inside as seen in this window here. We're going to go ahead and configure our gateway to have the partners for these devices. So that would be a master for the Modbus, controlling station for 101 and 104. So once I do that, I'll be able to go to my simulation here and make changes, and we should see those values change within gateway. So let's go over to our gateway. This gateway is what it will look like when you first start up gateway. There are no devices and there's no data within the middle here. So let's go ahead and start creating some devices. So I'll just go to the gateway root node, right click, and come down here to add a TCP/IP controlled station. Now, it doesn't have to be TCP/IP. You could do serial connections as well if you just look a few more down. But for this example, I'm just going to be doing TCP/IP. So I'll click that. I'm going to go ahead and create a Modbus master, so MB master Modbus. I know that this workspace is designed to run on a single computer, both the gateway and DTM, so I'm not going to change the IP addresses, but if you did have specific IP addresses you're connecting to, you would want to change the physical channel and also the local TCP/IP address. Since I know by default Modbus uses port 502, I have that set here and I don't need to change it. So all I really need to do is give it a name. So I will name this the master Modbus and do an underscore for the port number. This is just an easy way for me to keep in my head, just with the names alone, where they are connecting. So I could put potentially the last octet of a IP address or the port number, and we'll see I did the same thing over here in DTM. So now if I click OK, it'll bring up some advanced settings. I haven't changed any of the advanced session settings information, so I can leave that. And it will ask me to go ahead and add a data type. Now we have coils, discrete input registers. I'm just going to do coils for now, but I'll show you how to add additional data types afterward. I'll click OK. And now we have our coils. You'll notice that this is just a folder and there are no actual values inside. So we can add values by right-clicking and doing add MDO, that's a master data object. And then giving the object address, so that's the point number, so this is 0. If I click OK, now we have a point within the SCADA Data Gateway. Now if you have 100 points and you don't want to do this 100 times, you can come in and right-click and add multiple, and then say from 1 to 9. I think there's 10 of them total. So I went ahead and added all of these points. I also can look back at my Modbus here and see I have input registers as well, and they are labeled from 0 to 9, or you can check that on your physical device. So I can come in here and right click, add a data type, and I'll go down to my T3 or my input registers, right click, add multiple, from 0 to 9 again, and now I have access to all of my binaries and all of my input registers, the analogs as well. We'll get to actually how to bring that data over in a second, but let's go ahead and create the partner devices for my 101 and my 104. We can already see that the Modbus slave has turned green, which means it is connected. So, as well as looking down here in the logging section here in our gateway, I'll also be able to see the connection in DTM. Of course, if you're using physical devices, you may have other ways to see when the devices are connected. So I'll go ahead and add another controlling station or client or master. I'm going to select 101. Again, because I'm not changing any of this and I want it to all be used on the same network, I'm not needing to change any of these parameters here. So I can come down and do master 101. Again, this is a name I've used before, so it uses the same port number as what's on the device here. If you do need to change these for connection to physical devices or through gateways or whatnot, you obviously can add those values here. Again, I didn't change any of the specific information, just wanted to get the devices up by default, but you can look into things like the link layer addressing application layer. Different types of settings can be changed in here. Specifically, I would look at the link layer address, as sometimes you might see a change for 101 and 104, and you want to make sure this matches the device you're connecting to. I'll go ahead and hit OK. And just like with Modbus, it's going to ask you to add a certain point. So I can come in here and see now I have my 104 master. It is connecting up to my 104 controlled station. And if I come down, you'll see we have our single point here. Just like Modbus, I could come in here and add different data types and maybe add the double bits, right? And just do that just like we did before. But with some of the other protocols that allow for generations through like general interrogations, you can just right click and do auto create tags, and it will go through and find all of the points. Not only did it add the measured value here for my T9s, it's even gone through and added all of the points to each of these folders, these data types. And if I go in and I look at my 101 device here, we'll see that's exactly what I have. I have 10 of each of the binaries and double bits and 5 of the measurands. And sure enough, you can see that here. We can go ahead and do the exact same thing for adding in 104. As I'm sure you've seen this a few times, I can go ahead and kind of go through this quickly. I would like to note, obviously in a normal situation, you'd be using different IP addresses, but since I'm using this all in loopback, I did need to adjust the port numbers a little bit. So I just incremented the hundreds value here to indicate 104. So when it has a 4 in the hundreds, that's my 101s, and when it's 104, I just increment that, so it's 500. We'll go ahead and do this, give it a name. Go through the settings, and I'm going to go ahead and right click here and do auto create tags. And just like the previous device, we've gone ahead and pulled in all the points. Now we'll see over here in DTM that all of these are connected, and since all of the devices in this folder is connected, the folder is also indicating everything inside is connected, and that even goes up to the RTU section. Now, the question is how do you get data into the gateway? Yes, we have the actual values here, say in this coil, set to off. Those are the initial values. But if I go into DTM and I make a change to that Modbus coil, say we'll move it to on, and apply that change, what we'd want to do is see that value come across the line here. So, how you can do that is going up a level to this L1, you can go into what we call action masks. And this action mask is telling Gateway how you expect to receive data. So I can go over to it, and currently it's set not to do anything. So here's coils, holding, discretes, inputs, etc. I can come in here and say I want to read all of the points, or I want to read all the points between a range. So say 0 to 5. I'm going to do all the points, and then if we come over here, we'll also have these T3 input registers. So I'll go down to the input registers and I'll read all of these as well. So if I come in here and hit OK now, I still technically haven't enabled it because of this action period. So let's say I want to read this every 2 seconds. So if I hit OK now, that action mask will become enabled. And if I go out here to the coil, we'll see this value has changed. And that's because every 2 seconds, we're reading all of the values associated with these. Now, if I come in and take a look at this data and change it to off, and click apply, if we come back in here, we'll see that the value is off now. So that's one way you can read the data. Another way is you can set up a different action mask based on the protocol that you're using. So I can go into 104 or 101 and come into these action masks, and we have some different options for 104. So we can do general interrogations, we can interrogate individual group numbers, you can pull in for like 61850, report control blocks, report by exception for DNP3. We should have all these options in here, as well as a period. So this is like once a day, because this is in milliseconds, or I could come down and put 2000 here for every 2 seconds. So general interrogation every 2 seconds. I also have my controlling stations out here set up to automatically issue changes when they are sent. So if I click OK here, I can go into this single point information, or maybe we'll go into the measurands and go to my, let's see, this is 104. And here, I can set this to 100, 1000. Go ahead and apply those changes, and we'll see that value coming across. Now you might notice that some of these values are out of sync. So because I have it set up to send the data over on change, I can just go ahead and say change all the values once. This is a feature within DTM. So if you've got a auto data change, you can tell DTM which values do you want to change. So I just did all 30 of each of the point types inside of my DTM. And for Modbus, I've got those 20 points as well. I can change them every 1 second, or you can set up whatever period you'd like. Or you can set a percentage of the points. So I'm changing every 1 second when this is running, and I'm changing 50% of the points included in this list. Meaning every second it's going to grab a random assortment of 50% and change those values. So if I hit OK here, I can just change the values once, and then I'll go through and change all of those values. Or I can come in here and do start auto data changes, and now every 1 second these values are all going to change within DTM, and we should see them coming across the line here in our SCADA Data Gateway, which now we're seeing these values update corresponded to the values inside of the DTM. Now that we're getting the values from our simulation or from our physical devices, if you're not running DTM as your environment, the next thing that we're going to do is map these over into a slave or server database within our gateway to report up to our SCADA master. So we'll get on that next. So now that I'm getting data in from my simulated or physical RTUs into my gateway, I need to then concentrate all of this into a database for my SCADA master to access. For this demonstration, I'm going to be using a SCADA master for 104 and an additional one for DNP3. So following the same logic as before, you can go up to the gateway root node and right click, and instead of adding a controlling station or client, we're going to add an outstation, controlled station, or server. From here, we're going to configure it in the exact same way as last time. So I'll come down here to do a SDNP, that's our outstation. And again, because this is all doing loopback, I don't need to change any of these values here. So I will go in and say DNP3 outstation and port 20,000. Now again, this is just a habit that I do for me to be able to see from the root node here exactly where the ports are. You don't need to name them in a specific way. So I'll go ahead and click OK. Again, you might want to keep an eye out to see if there's any specific configurations, such as your link layer addressing when you're connecting up to your SCADA master, but I didn't change any of that. And I'll go ahead and create the database. So we'll go ahead and see our SCADA master has connected on a TCP/IP level, but currently if I looked in the database, there'd be nothing to show for it, because there are no points inside of here. So I want to go ahead and map over my binaries, my double bits, and my analogs from the various devices we're pulling data from. So I already got binaries. Let me go ahead and add a double bit. And I'll go ahead and add, let's say, an analog input here. Great. Now I have the different folders needed for each of these different data points, so we can go ahead and start mapping things over. There's a few ways you can do this. For instance, if I just go down to the coils of the Modbus, I can just grab this value and just drag it over to the binaries, and it'll automatically suggest a mapping for me. So it'll say, do you want to create it inside of this T1? Yes, that's where I dragged it. And the object information address 0. If I click OK, I have now successfully mapped that Modbus point T0P0 to our DNP outstation database here, T1P1. Now, I've closed that window. I no longer see that mapping anymore. You can still see that in the database view here in the gateway. So we'll see this is the point here, T1P1. It's coming from, the arrow is pointing to, it's coming from the Modbus master port 502 L1 T0P0. If I accidentally configured this incorrectly, I could click this delete mapping button and it'll get rid of this mapping. Or if it's correct and I want to get the rest, I can come down and repeat the process. Again, you might have 50 or 100 points. You don't want to do this one by one each time. You can just multi-select all of these guys and drag them all at once. And it will ask you on an individual level, is this what we expected to be the mapping? So it's just incrementing them by one each time. That seems fine for me. So I'll go ahead and hit OK. And sure enough, now we have all of the binary points mapped over from the coil to the outstation database that we're providing. And I can repeat this process for our 101 devices and 104. So if I just come in here and grab these guys, drag that over to our binaries. Again, it's coming from T1, P1 on this 104, but we're still incrementing these numbers. Click OK. And you get the idea. We can continue to do this with the other values as well. This is probably the last one I'll do for binaries. Drag these guys over. So now we have all of the binaries in our DNP3 master mapped over. So we have 10 from each of our RTUs. So we've got 1 through 9, 10 through 19, and 20 through 28, or however it's divvied up in that way. You can actually just check the mapping to see exactly where those numbers are coming from. Following that same logic, we could go in and do that with the double bits as well. So I can come in here and move these double bits over to our double bit. Hit OK. Same with our, let's see, we did 104, so we want to do 101. And then obviously we have our analogs as well. Go ahead and drag these over. Now, if you have hundreds of devices, or you have, lots and lots of points you can't move over at the same time, you can export out this into like a CSV and an INI folder, and you can use the powers of find and replace and Excel and things like that to kind of map this stuff for you automatically. I suggest doing like 1 or 2 of these points to get the idea of the formatting, and then make the changes as you need to move these over. So now I've got all these points pulled over, and they're pointing outward from the gateway. If I come over here to the master and do show data points, it'll go ahead and bring up a list for me. Now let's go ahead and get these values. So I can right click on here, and I'm just going to do an integrity data pull and just execute on that. And that will go ahead and populate my data set here. So if I group by type here, we'll see I've got my 30 or so binary inputs. I've got my double bits. There's a little bit less of them, and same with the analogs here. But I am getting all these values across. We're still changing data. And if I go ahead and say in DTM, instead of doing a single integrity data pull, if I do like enabling unsolicited messages, right? I can execute that command over to our gateway. And now anytime our gateway is changing data, it's going to go ahead and show up here in my data window. So as these values change, we should see them changing in this data window here. And again, we're only doing 50% of the values at a time, so we're only seeing a few of them kind of toggle over. And in order to do this in 104, you pretty much just follow the exact same process. I'm not going to go through it as thoroughly in detail. I just know we hadn't seen DNP very much so far. But yeah, you just right click. You can go ahead and add a, this would be the database pointing outward to our SCADA master. So it would be a controlled station. We would select 104 just like previously. Again, for my 104, if I look back at my pattern here, this would be at port 2505 because it is 104. Most of the time you're going to be using unique IP addresses, so you wouldn't have to worry about that so much. So this is a 104 controlled station 2505. Go ahead and add all this stuff. And now we have access to the data points, just like before. We can add new data types, so to the double bits, we can add the measuran values or whatever values you particularly need. And just like previously, you can go into any of our SDOs or slave server data objects and just kind of drag them over as you need. So we've just, for our most simplistic form here, we can grab all 9 of these guys and drag that over. Go ahead and hit OK. And just like with the DNP, you can build up your database this way. And just like in the master side of things, you can go ahead and show the data points here and issue any sort of like general interrogations or whatnot in order to get your device connected. So at this point, we went ahead and we've added in all of our RTUs as masters or clients within our SCADA Data Gateway. We've pulled those values over into the databases associated with those masters. Then we created the outstation slave server databases necessarily for our SCADA masters and mapped those values over from our RTUs into this outward data concentrated database and sent those up to our SCADA masters. So hopefully this video has helped you learn how to configure your devices. We'll make another video like this for 61850 and ICCP. That way we can look at more model approaches rather than just the database type protocols that we've looked at in this video.